In order to discuss functions, we first have to define what a function is. To define what a function is, we have to define what a relation is. A relation is any set of ordered pairs. A function is a specific kind of relation. It's a correspondence between a first set, called the domain, which we've discussed previously, and a second set called the range, in which each member of the domain is assigned with exactly one member of the range. A function could be a set of ordered pairs where the first component corresponds to exactly one second component, and we often use x and y to represent these, the domain and the range. I like to think of these also as inputs and outputs, for a reason we will see in a little bit. Now let's see if we can identify a function given some information. Determine whether the relation is a function and give the domain and range for this relation. So we always have a domain and range, even if it's not a function, but we use those to determine if it is a function. So let's go ahead and identify the domain. Those are our x values, or our inputs. So those would be 7, 20, 31, we've already listed 7, so I'm not going to list it again, 47. That our domain is the set 7, 20, 31, and 47. Now you might notice that 7 occurred twice. I didn't write it twice, but it did occur twice in our domain. Now our range will be the outputs, or the y values. So here I'm going to say 1, -6. I'm looking here. 6, 1, 6, 6. Well, we already got 1. We need 6, and we're not going to list it again. In a set, you only list things as they occur. All right, now, how we know if something is a function is if the inputs, if the domain values match with exactly one y value. Well, notice I said earlier that one of our x values repeated. Well, there's one x value that does not have exactly 1. It has 2, not 1, but 2 y values. That means this is not a function. We have a domain value, an x, that has more than one y value. Now we can use that idea in this next type of function. We actually have 3 different relations here. Is each correspondence a function? Yes or no? Well, with an arrow diagram, which we have here, we look at the inputs matching to the outputs. Do any of our inputs, or x values, correspond to more than one y value? Well, yes. So this one is not a function, because 9 matches up with 2 different y values. Now, the second one is a function because each of the inputs matches with exactly one output. Now, this last one is the one that generally trips us up. Looking at our x values, each of our x values matches with one y value. Each of them matches with 1. It is all right, it is acceptable by our definition for our y value to be, quote, hit, or to be mapped to more than once. So this one is a function.